Hi, I'm David Jedynak. I'm the VP of Strategy for Curtiss-Wright Defense Solutions. Have spoken at ETT previously in previous years. Promise this time, for those who remember, no tears this time, please. About 10 years ago, a lot of folks within the defense industry, our primes, government labs, et cetera, if you said VPX, they had no idea what we were talking about. Now you can see clearly our government customer is really driving the adoption and the charge of using our standards, VITA standards, in the government. They're helping define those. 10 years ago, Ben Petticord and Jason Durner joined, as part of the US Army, joined the board of directors of VITA to help start driving. At that time, it wasn't even called CMOS, it was hardware software convergence. So we expanded our tent, basically our main tent. We said, let's actually get everybody inside of this thing and grow our market. And there's the adage, rising tide lifts all boats. It's important for all of us vendors in here. If our market is growing, then that's good for all of us in terms of our business. And that was the goal. It's like, how do we make sure that our market is fully adopting what it is that we're doing? It's been 10 years. It's time to broaden the tent. So this concept of boards and backplanes in boxes is not new, right? That's what we do. It's not new. It's well understood. There's maintenance concepts. There's the cost and value trades. It's cheaper to actually have a bunch of boards versus a couple of standalone boxes. The architectures we understand, the environments we understand, the performance requirements, the security, all of that is well understood. And here's what's interesting. It's been around for a long time. So in the left here, you can see it's like a TV camera, right? And you open the side and there's just a bunch of cards going into a backplane. A couple of careers back, I worked in entertainment, and in the 70s, Dolby came up with something called Dolby Stereo, which was, surround sound for cinema, and it rolled forward from there. Now it's just basically in everything. But that was where, when I was doing my EE, I used to sit with the manuals of the Dolby Stereo stuff, pulling cards, Eurocard form factor out of those things and hacking them to make the system do other stuff, other sound formats, and kind of figuring it out. That's just 19-inch rack mount, multi-card, backplane, the whole thing. Those still exist. That just happens to be the models from the 1970s, but they just continued forward all the way till now. And you still go to a cinema and you open up the Dolby processor and there's a bunch of cards. The interesting one was a couple weeks ago, I was at JSC doing the tour with my kids. We've been there before, and there we are looking into the command module, or not the command module, but the fairing on the Saturn V that's at JSC, where the lunar module would be. And look at that. There's boards in backplanes in boxes with like mil standard connectors on the side. So that's in the big section right behind the command module. And you can see it's dirty and dusty because it's left out in the rain, I guess, for a bunch of years, but that's what's there, and that concept has been there for a long time. So we shouldn't have to think about pressing the point of boards and backplanes in boxes being a good thing. It's well understood. There's a lot of history there. We're proving it in defense. It's been done in other industries. But really, we need to think about where we can go after this. So let's think quickly about what we're doing. Today, we're in aerospace and defense. That is what we do. And because of that, we think about the environments that we have to service. Those are extreme environmental conditions, right? We've got vibrations and temperatures and thermal shocks and maybe radiation environments, whatever it is. It's really extreme. So it drives us to do a lot of ruggedization of what we do. The performance is usually more important than the cost. Even when it comes to the lower cost applications in our environment, it's still, a single board computer is still like 10x what the laptop equivalent would be if you go to a big box store. The other thing is we're having to meet defense buying behaviors. So we all understand defense buying behaviors are governed by the US government, and sometimes it's governed by things like continuing resolutions. where there's no budget and it screws up the buying cycles and all those different things go into it. It's not a normal business to business or business to consumer sort of buying cycle where it's, hey, it's Christmas, we're going to sell more game consoles. It's a different sort of thing. We have long-term sustainment issues that we have to support. So that's driving how we think about our business and our standards and what we do. So when you look at things like VITA 47, it kind of struck me. I said, well, what is VITA 47, which governs its ruggedization standards? I said, well, what's the least rugged? And I went, wow, that's still pretty rugged. It's like, and then we keep adding numbers. We're up to like VITA 47.4, and I'm thinking there's some markets that need like VITA 47 dot like -10, right? If you're just going to take it as a scale, we're starting at a very rugged point. Like for instance, vibration is in VITA 47.0, and I'm like, well, in a fixed install, yeah, you care about vibration because it's going through like FedEx, and that's about it. We're always focusing on these top performance, constraints in these environments. That's great for what we're doing, but not necessarily for broadening the tent. So what does broadening the tent mean? I don't mean a big box store and we're going to go sell VITA computers at, the local big box. That's not what we're talking about. What I'm talking about is everything else that's non-consumer. And I know this is an eye chart, so you can see it later, but I'll take you on a tour. Bottom left, infrastructure, smart infrastructure, so instrumented bridges, right? And right now there's just a little box sitting somewhere, right? Underneath those bridges, the whole concepts of how you do that, and it's all very bespoke. Voting machines, maybe, maybe not, but that's an interesting place where you've got a lot of bespoke gear. Should there perhaps be some standards applied to all of that? You look at just below that, there's charging stations for electrification of the roads. There's a whole concept. In fact, this is an interesting one. There's a snapshot from a slide there about public infrastructure network nodes, PINs. I actually talked to a guy in Austin who's running this group who actually heard about our standards because he was talking to somebody at the Air Force who said, oh, you're looking for an open standard thing, so government and millions and millions of nodes across the country? Yeah, there's this thing called SOSA, and you should look at that. And he started getting connections there, and he and I were talking about, well, yeah, this kind of makes sense, except I thought we're probably still too costly for what he needs because these things are on the side of the road, not, flying, hopefully. And therefore, maybe the ruggedization needs to be a little lower to worry about cost. You look, there's a sort of a cluster there, agriculture, water treatment, autonomous, farm equipment, autonomous drones for, spraying fields, et cetera. Rail is a huge mess with all the electronics there. And I started looking for pictures of some of the stuff, and it's just a rat's nest of stuff where it could benefit. Medical. You open up some of these things, you look at the nurses' stations that roll around, and you stare at them long enough, and you realize this is just like a cheap little computer, just like dipped in white, and there's always cables falling all over the place. It's not very elegant, and they go down all the time. They're basically glorified point-of-sale machines getting pushed around on a cart. Telecom, obviously, there's towers all over the place. There's a lot of data running through those, a lot of stuff, and at the end of the day, there's a hut. And inside that hut, there's some air handling and air conditioning, and then there's a rack full of just junk. It's not really junk, but it kind of is. It's just kind of this commercial stuff thrown in there. Supercomputing, right? That's a huge problem with supercomputing, the cooling, the dealing with reliability and how often the thing is going to have an upset, that the whole thing has to reboot. People are always coming up with novel ways to do it. How about some open standard ways of doing it? As we keep going over to the right, you start to see things like there's energy, there's wind, there's solar. Obviously, they all need electronics. Upper right, obviously, Industry 4.0 type things, robotics, et cetera. So a lot of people doing stuff with robotics. The key there is not the processing. The key is all the biomechanical, if you will, mimicry. And even on the bottom right, broadcast and entertainment. So in electronic news gathering vans, they have tons and tons of stuff in them. But some of those are getting into harsher environments and whatnot. Maybe there's something we could be doing there. And even things like stagecraft or the volume, where basically these massive projections and shows like The Mandalorian and other are shot with these massive video walls. They have this huge pile of graphics processing units basically simulating a world. That's hard to put together quickly, and you got to make sure it runs. And maybe we need to be looking like, could we bring some reliability to that world, where every minute of time in production costs thousands and thousands and thousands of dollars. You don't want downtime. So when I look at these target markets, critical infrastructure, critical national infrastructure, and I'll read off some of these quick. These are defined, the US government has defined critical areas, so the chemical sector, commercial facilities, stadiums, et cetera, communications, manufacturing, dams is its own sector. There's a whole bunch there, but basically these are all areas that are considered weak spots in our infrastructure that could be hardened. So Industry 4.0, supercomputing, medical, as I mentioned, broadcast, entertainment. Heavy industry, I didn't really put something on there, including off-world. We're starting to see people say, I want to do off-world, which would be more rugged, but you got to start by proving what we could do with our standards here first. And they go, oh, okay, so we're going to have a VPX card, you know, in a chassis, and we have a bunch of those, and we install those on the massive truck that's doing the thing, and that makes it autonomous. You go, oh, okay, I understand that. Okay, great. Now when I go to mine that asteroid, I'm going to use the same thing. And then IoT everywhere, wherever we can with IoT. I know there's a lot of cheaper stuff out there, but ultimately there's no standardization of how it's packaged. So here's a call to action. We need to understand each of these different markets if they're interesting. So first and foremost, there's businesses. Like, is it worth going after, I don't know, selling millions of cards in a new market? Probably. But we don't know for certain what are their optimizations. So in ours, currently, it's performance usually over everything. Well, are there other ones where they're like, it's cost? In telecom, it's truck rolls. If they don't have to roll a truck, which costs money, to a tower to go fix something, that's a benefit. So maybe an upfront cost that's higher would be worthwhile if it means the number of truck rolls per year goes down. Which of them have standards, which don't? I mean, if you look at industrial control, there's a lot of stuff with these DIN rails. It's kind of a standard, or there is a standard, but there's a lot of sort of de facto in that. Which ones have it, which ones don't? Looking at new markets, things that are new that really haven't happened before. Robotics in automation with actual human form robots. They're new. Maybe they need something that it would help solve a problem. It would be would provide their back office, you know, for their Drucker-style front office of robots. Which are ones that are just like railway? It's like, this is just a mess. It's time for a change. Let's make a change. The other one too is that there's some of these markets it's going to be hard to touch because there's already entrenched vendors. They're there. They have a lock on it. Don't touch it. So this is part of that market assessment. What are the needs today? What are the needs tomorrow? We've got to understand each one of these markets first. And then once we understand its requirements, start looking at the applicability. Compare and contrast, right? What's the same? Oh, they've got a thermal challenge. We know how to do thermal. Great, that's the same. They're fixed install. We're all, you know, about vibration and acceleration. They go, that's not the same. We got to change it. The speeds, the connections, whatever it is in terms of the way that we design in aerospace and defense versus what they need, some of those things will be the same, some won't. Understand that. What are their performance requirements? What are their environments? Right? What's the environment in the hut next to the cell tower? What's the environment in the MRI machine? What's the environment in, you know, underneath the bridge where needs to be all these sensors? What are the environments in the pins alongside the road, et cetera? Understand all those things. The maintenance requirements, the security requirements, all those different things, understand that. Then what I'm proposing, so that this is the how do we go forward here, is should we, understanding all of those things, say, hey, let's go to VITA 47 and say, let's do VITA 47 dot -1, -2, -3 for the less severe environments and capture what those are. Even if we're not going to do anything with it for right now, let's at least say we understand. Telecom needs this, medical needs this, under the bridge needs this, the Industry 4.0 needs this. Power inputs. We're a 28 volt centric world. Automotive is 12, with 12 to 15. There's other stuff that's in the 40. There's these different levels, different types of power. We have to understand those things and say, hey, VITA 62, which is our power supply standard. Let's start listing out all the other types. VITA 65, are all the topologies that we've done, do they all make sense? Are they good enough for all these other industries? Or are there some things that are radically different? Capture those. VITA 48, just the way it's packaged, right? We've obviously done it so that the soldier can do it in the field and stick it in and it's great. Okay, well, what does it need to be for dams? What does it need to be for robotics in an industry, in an industrial plant, et cetera? What do those factors need to look like? Do we need to dial way back on the ruggedization, different types of wedge locks, different types of connectors? The VPX connector, right? We've talked about higher signal integrity and better performance in vibration environments. Well, let's go back to, well, we don't care about vibration. Can we make the connector cheaper so we can sell more of them? And then what else? It's VITA new, right? What are the new things that we need to do? So when I look at this, I say we sort of won the point. The defense industry has fully embraced VITA. It's a part of VITA. It is truly of, by, and for, right? What's next? What's the next market? Where can we go next? How can we understand that? So in the last slide, I'm just saying ETT in 30 years. So I thought I'm gonna end with a really awesome slide that shows like this massive tent, and we're gonna have like planets inside of it, and it's gonna have a VITA logo on it, like the VITA logo. And I spent like an hour banging away with AI trying to make this happen. My 12-year-old comes home. What you doing, Dad? Comes over and looks, and I'm like, well, I'm trying to do this. And he goes, okay, give me a sec. Runs off up to his room, pops up Microsoft Paint, and 3 minutes later he Skypes me, because that's what we do in our house. He Skypes me this drawing, and it was like, and he even put the numbers in there. I didn't ask for that. That was a little extra creative thing there. 1996 to 2054 with his little VITA logo and the whole thing. And I'm like, maybe in 30 years, AI will actually do what you ask it to do. I even fed it the VITA logo, and I said, put exactly this image in the picture, and it came back and said, would you like to know more about VITA standards? Because it figured out VITA was in the logo, and I'm like, no, just stick it somewhere. Anyway, so hopefully, as we come back over the next bunch of years, we start talking about, yes, and now VITA owns railways. It's like Monopoly. Anyways, thank you very much. Thank you for your time. Hope to see you in the future as we talk about things other than defense.